Hello and welcome to Minerals, Rocks, and Fossil Talks. I'm your mineralogy teacher, Jen, and it's time for Wordplay Wednesday. We're going to talk about fluorescence. Fluorescence, named after the mineral fluorite, from whence it was first observed, is a property of minerals and other substances where they absorb light and emit it at a longer wavelength. When fluorite or other fluorescent minerals are placed under ultraviolet light, a photon of a specific wavelength is absorbed, causing an electron to get excited and move to a higher energy level or a higher shell. When the light source is removed, the electron immediately loses energy and drops back to its original energy level in its original shell, and it no longer glows. So, I've got a bunch of fun stuff to show you how fluorescence works. So I've got two different black lights. I have a short wave and a long wave black light. And basically what that means is that they are different energy levels. So long wave ultraviolet light means that it's a lower energy, usually between 320 and 400 nanometers. And then the short wave is a higher energy. And the reason you have two of them is that some of them fluoresce better at long wave and some fluoresce better at short wave. So let's test some of the stuff I have. First off, I apologize. My cat is over here snoring, so you'll probably hear him through this part. Just ignore it. I have a whole collection of things that will fluoresce, so I will turn the lights off, get my UV lights out, but I'm going to show you what's here first. Like I said, I have a wide variety of things. I've got fluorite, which right here. I've got calcite, selenite gypsum, 2 pieces of corundum, another piece of calcite, a bird egg, a fun skull that I got from a rock shop, a shell, apatite, fluorite, a fossilized shark tooth, what I think is a deer tooth. I don't know, it was a gift. Lots of people just are like, oh, you're a paleontologist, have a bone. Got some more. These are snail shells I found on the mountain. This is some sort of probably deer toe. Again, gifted. This is caliche that I got off the Morrison Formation. A painted shell someone gave me. Another gift I was given, probably a deer vertebrae of some sort. And some chalcedony. There's a fun little cell that I made that has some fluorescent pieces to it, and then of course some more shells that came out of the Jordan River. And then of course my shirt. So all of these things are going to fluoresce to some degree or another. Ready to turn off the lights and see? So first I'm going to use the short wavelength. So let's see what happens. Alright, first up we've got our river shell. So far, not a ton happening. However, if you look at our shell, or our cell, we've got lots of little fluorescent beads and pieces in here. You'll see pinks and blues popping up. Not much happening with the chalcedony. It's still kind of violet, not doing its thing. The bone, not showing a whole lot. It's a little blue. got a very bright pink shell. What I want to point out on this bone, you can see there's some orange on there. Something got left behind. Our snail shells are kind of turning a purple, so not much happening there. There's a little bit going on with our deer tooth. Hopefully you can see there. It's so hard to make it so that this is, there's a little bit going on with our shark tooth. It's turned orange. Our caliche has turned orange. Not much going on with this piece of fluorite. Looks blue in there though, so maybe the camera is catching something I'm not. So that's what color fluorite's supposed to be. Blue. Apatite is supposed to be kind of purpley blue. Some very orange calcite here, very orange. Corundum turns very, very red. Very red. Selenite is blue. Selenite gypsum. We get more, a little bit of orange from the calcite. Nice. Some blue off of this fluorite, maybe. The inside of the eggshell is kind of fun, with some orange on the outside. That. A little bit off of orange off of our shell here. And then this guy gets all sorts of speckly. Now for long wave. You'll notice I have to get a lot closer with my long wave, and you may not be able to tell as well. However, the corundum is still very, very red. If I get up really close, you can see how blue this fluorite is. I mean, look at that. It's beautiful. See how orange this calcite is. Very, very orange. With our chalcedony, you can see it has turned green. It is a red chalcedony that has turned green. And then, of course, you can see the shirt still fluoresces as well. Well, thanks for coming to today's lesson and looking at some fun fluorescent things with me. And make sure you tune in tomorrow to learn about the scientist who first described fluorescence. And I will fossilization later.